Hi, fourth grade. We're going to continue in our math lessons this week with Chapter 23, Lesson 7 on area. You can open up your textbooks to page 608 and get your journals labeled with 23.7 area. As a reminder, we are going to be working with both perimeter and area in this chapter. The two go hand in hand, but they're very different things, so it's important that you understand the difference. Yesterday, we started working on perimeter. The perimeter of an object is the distance around the edge of the object. We find that by adding up all of the sides of the figure, the side lengths. Then, what we're going to be learning about today is the area. Area is the amount of space inside a shape. Now, there's a special way that we calculate the area using a formula, and each shape's area is found with a different formula. So today we're going to be working on just calculating the area of squares and rectangles because the formula for those shapes are similar. But there's a different formula for triangles, there's a different formula for circles. For every shape has a different way to find the area because each shape inside looks differently. So we don't have one dry cut formula to use for all of them. One thing that you are going to notice today is the way that we label the measurement of area is different than how we did perimeter. When we were working with perimeter, we labeled it just with whatever the unit was that the side lengths were measured in. Well, because area talks about the entire space the figure is taking up, those are called square units, because if we were to break the shape or figure into squares, we could count how many squares covered the whole area. So that each one of these little squares that is taking up space on the figure is called a square unit. Now, sometimes you'll be working on figuring out the area of figures that don't actually tell you the unit that it's being measured in. So if that's the case, we always just say square units. But if they do tell you the side lengths and the unit that it's being measured in, for example, in this figure here, it's being measured in yards, we would say square yards because it's not just a yard running in one direction, it's a yard running in both width and length, all together to equal that square yard. Now, sometimes you'll see it written out as square yard or square unit, or sometimes you'll see it written out like this with the shortened abbreviation and a little 2 up above in the top corner after the last letter. That symbol, the little small 2, is the symbol to mean a square unit or a number squared. The formula for area, we'll write this down in your journal so you can write down formula for area. The formula for an area of a square or rectangle is A equals length times width. So all you need to know in order to solve the area of a rectangle or a square is the side lengths of the wide side and the long side. Here, I want to show you an example so you can rest your pencils for just a moment. Here I have this rectangle. I can see the side lengths are measured out. I know that my formula is A equals L times W, area equals length times width. So to find the area, I plug in one of the lengths, which is 4 centimeters, and I multiply that by the width, 12 centimeters. Then I can do that calculation. 4 times 12 is 48, and my label is centimeters, but not just regular centimeters, centimeters squared, because I've multiplied centimeters times 7 centimeters. There's 2 of them, which makes it centimeters squared. All right, I'd like you to start practicing with me, and as we practice, I want you to remember that this formula that we're using only applies to rectangles and squares. So keep that in mind. This formula, area equals length times width, is only good for rectangles and squares. All right, let's get started. This square is 12 centimeters all the way around on each side. So I know the length and I know the width. A equals length times width. I write a cursive L for the letter L because an L looks like a 1. So whenever you see that in a math equation, it's best to write it as a cursive letter if the normal letter can look like a number. So then I'm going to plug in my numbers. The length is 12 centimeters and the width is also 12 centimeters. Then we'll multiply that together. 12 times 12 is 144. And then my label is centimeters squared because I'm multiplying centimeters times centimeters. Since there's 2 of them, that means that they are squared. All right, let's keep practicing. Number 2. This rectangle here is 10 by 12. Area equals length times width. I want you to practice writing that out with me so that you remember the formula. You won't need to do that on your independent work, but I would like you to write that out in your journals. So our length is 12 and our width is 10. To find the area of this rectangle here, the space inside the figure, we're going to multiply the length, which is 12, times the width, which is 10. We're working with inches here. 12 times 10 is 120. The label is inches squared. Because we have inches multiplied by inches. There's 2 of them, which is where that 2 comes from for the square units. Number 3, we have another square that we're working with. The area of a square is length times width. Both the length and the width are 9. We do 9 times 9. The area equals 81 miles squared. You could also write it out like this, miles squared. I would much rather shorten it, but either one is okay. Number 4, another rectangle. This rectangle is 6 meters by 16 meters. Our area for a rectangle is length times width. The area is equal to 16 times 6 meters. Now, I do not have my 16's facts memorized, so I'm going to type it out in my calculator. If you'd like to be doing that as well, that is okay. I get a total of 96, and my label is meters squared, or square meters. Either way to write it out is okay. All right, so every problem is going to be just like that. So that's all I'm going to show you to practice with. I'm going to let you get to practicing more quickly. This topic is a little bit more simple, so I think you guys are going to do a great job with less support from me on that. But I do want to show you a couple ways that area can work together. So we're going to use this picture from your textbook. This is for numbers 15 through 17. We're going to just solve numbers 15 and 16. And there's a lot of different figures happening here. Now, the main rectangle here is this whole backyard area. And this is 20 feet long by 15 feet. And so, however, within that, it's not all one material. We have some of it is grass, some of it is gray brick, some of it is red brick, and we have the measurements for each of those as well. So be aware that although the main rectangle is one large rectangle, we have two smaller rectangles, the red brick and the gray brick. And we also have this odd patch of grass that has a rectangle here and then 2 smaller rectangles there. So just be aware that this is going to complicate things a little bit for us as we try to figure out the area of these different materials. You will have a set of problems like this on your assignment, so get ready to think outside the box a little bit. Let's go going number 15. Number 15 asks, the gray brick is a square. The area is a square, so that's helpful to know. That means that this side is also 10 feet, this side is 10 feet, and this side is 10 feet. How many square feet of gray brick does Mark need for that area? Okay, so that's easy. We just have to look at the gray brick. The gray brick is a square. Area equals length times width. For this square, the length and the width are both 10 feet. 10 times 10 equals 100, and my label would be feet squared, or it could also be written as square feet. All right, number 16. This is where it's going to get a little sticky. So, the area surrounding the patio is grass. How many square feet of grass does Mark need? Explain. So, let's take a look at this. I'm going to get all of these lines that I drew off of the figure so that we have a nice clean picture to look at. So, this problem is asking us just to solve the area for the grass. Now, I want you to take a look at this figure. What problem are we presented with by needing to find just the area of the grass itself? Is this a perfect rectangle? No, it's not. We have this piece of gray brick that is cutting in between what would have been a perfect rectangle. Since we don't have that perfect rectangle, we have to think outside the box a little bit. We know, so far, we know that the measurement of the gray brick is 10 feet. So that covers to there. So it should be the same on the other side. So we know that this is also 10 feet here. But we do not know what this extra part is here. We also do not know. It doesn't label this side of the grass for us. However, we do know that the opposites are equal on a rectangle. So because we know this side is 15 feet, we also will know that this side is 15 feet. So there are two ways to go about solving this problem. The first way is we could find the area for each of these three rectangles. We have this first biggest one. Then we have these two second and third smaller rectangles. So we could find the area for each of those rectangles and then add it all together to find the grass. Or we could think bigger picture. And we could find the area of this entire rectangle here and subtract the brick from it. Either way is okay. I'm going to show you how to do both methods. So let's work first with the second method I mentioned, which is finding the area of that purple area that I just outlined, the whole grass and gray brick combination. So I know that this entire patio from the red brick to the edge of the grass is 20 feet. It tells me that up at the top. However, we don't need the brick part, so we're going to want to cut that off. I know from down here that it's 4 feet, so I'm going to take first 20 minus 4, and that's going to tell me what the grass is actually measuring. So 20 minus 4 is 16. So I know that this is the total for the grass is 16 feet. So that means that this part that's 10 feet, this is another 6. So that means this entire part here is 16 feet. that much is solved. Then, so we know the width now. Now we need to know the length. Well, I know the other side of this rectangle. We already know it's 15. So I found that first part. So the area is length times width. And we know the length is 15 feet multiplied by the width, which we found was 16 feet. I'm going to put that into my calculator. 15 times 16, which is equal to 240 feet squared. Now, that's not my final answer because that's covering this entire area here. We don't want that though. We need to get rid of the gray square in the middle. Well, from our previous problem here, we found that that's 100 square feet. So what I need to do now is take that total area, 240 feet squared, minus 100 to get rid of this middle patio. And that tells me that it's 140 feet squared. So my total for just the grass is 140 feet squared. That's just the green grass area. Now let me show you the other way, all right, with green to show you if we were to count up the rectangles for just the green parts. I'm actually going to write in red to show you this one that I marked with red, and then I'll use yellow to show you the yellow. So we already have found the answer, but I'm going to just show you another way that you could do it to think of it. So the other way that we could do it is by finding the area for those smaller rectangles that we've just split up. So I know that for the first biggest green rectangle for the grass, I know that one side is 15 feet. So for my area equals length times width, I know that the length is 15 feet. And I know from solving this before, doing 20 take away 4 is 16, knowing that this whole part here is 16 feet, but I just need this part, which is 6, because 16 take away 10 is equal to 6. So I know that the width of that rectangle is 6 feet. So my area here is 15 times 6, which equals 90 feet squared. Now that's just part of it. I still have those yellow rectangles to find. So now I need to find the area for those smaller yellow numbered rectangles that I labeled. So I know because of the square, the gray square brick, I know that this part is 10 feet, but I don't know what this part is here. So let's see if I can figure that out. Okay, so I know that this whole side piece is 15 feet. I know that this is 10. So that means I have 5 feet left over between the two of these. But I have to split 5 in half to figure out what these remaining pieces are. So 5 split in half is 2.5 or 2.5. So this is definitely proving to be the more complicated way. I think the way I showed you first would have been best, but we're already committed to doing this, so we're going to finish. So for that smaller rectangle, area still equals length times width. So we have, for the length, we just found it's 2.5 feet times 10 feet for the width. So I'll enter that into my calculator. 2.5 or 2.5 times 10 is equal to 25. But I have 25 for this and 25 for this. So I actually have 25 plus 25 for both of those, which equals a total of 50 feet squared. So now to figure out how much it is altogether, I need to add up the red area and the yellow area. So I have 90 from the red 90 feet squared from the red plus 50 feet squared from the yellow. 90 plus 50 is equal to 140 feet squared. So either way, I ended up with the same answer, no matter which way I solved that. Now, the way that I showed you first, finding this whole big rectangle and then subtracting the inner square, was a much easier way. But I wanted to show you all of it so that you know there's not always just one right way to do things. There's sometimes multiple right ways, and so you just have to try, and if it doesn't work out, then no worries. At least you learned that it didn't work out. So for your assignment today, I would like you to solve 23.7 PW. You're going to solve all of it. And one direction that I'd like to cross out that you need to make sure you don't need to do is in the second set for 4 through 6, it says use a centimeter ruler to measure each figure. You don't need to do that. It already has it measured out for you, so that's okay. But I do want to make sure you understand that it's asking you to find the area and perimeter. So please make sure that you find both. Remember, area is the area inside the figure, the total surface area, and the perimeter is the distance outside the figure. So make sure you look back on your notes from yesterday. When we have area, it's area equals length times width. Perimeter is the sum of all of the sides of the figure. So it would be side A plus side B plus side C plus side D. So keep that in mind as you work today. So thank you so much for your hard work. We will not have a Zoom meeting today. So if you have any questions, please feel free to reach out over class.